So it's live now. All right, guys. So today we're gonna be talking about understanding operators, understanding nulls. What is a null? Talking about primitive wrapper types, numeric promotion and casting, arithmetic operators, unary operators. Okay. So we're gonna talk about those operators today. So we're gonna start by creating a class here that's about nulls, okay? So we're gonna call the class. So if you're following me, just bring your IntelliJ up and let's start now. Okay. Guys, are you having any issues accessing the repository on GitHub? Any issues? No? Good. Okay, so we're gonna create a class, right? And we're gonna name the class understanding nulls. Okay? And we're gonna call that class understanding null. Now we're gonna create our dear friend, the main method. Okay? Good. So far, so good. Nice. Good. So now I'm going to create two static variables. Okay. Remember we talked about this before, like they are outside the main method, inside the class, but they're member fields. Okay. So we're going to say static, and then we're going to create an object here. Okay, we're going to create an object with the object type. Okay, guys, for you that don't understand the object is the ultimate class. So all the classes descend from object. Object is the class, like the father class. If you can relate this to daily life, object is like God, and then all the classes come from them. You know, if we can see it from a religious perspective. Okay, so the person that created, the genius that created object-oriented programming, he did everything like daily life. We have a father that is the father of all, and then you start having your own father, which you come from, and that's when we see inheritance. When we get to inheritance, which is one of the pillars of Java, of object-oriented programming, not Java. Object-oriented programming. And then we have the supreme father, which is the object. So all classes descend from object, okay? So I'm gonna create a class, an object here from the class object. And this is, like we've seen before, this is the way that you create an object, okay? By using the type, the keyword new, okay? So that's how we create an object. And it's giving me a warning here, it says that it's never used. I haven't used it yet, okay? Let me create another one. Okay. And then this one, I'm gonna do this. And then I'm gonna say my other object. But this time I'm not gonna do the new variable. I'm just gonna leave it that way. All right. So now inside the main method, I'm gonna create, let me create another variable, okay? Let me call it static, and let me call it, it's a string. Let me call it my string. And then I leave it that way. Now inside the main method, I'm gonna create another object. And now I call it my local object. Okay. And then I'm gonna create an object here, like I did before, right? This is not a local object. This is a static object. It's outside a block, okay? This is a local object because it's inside the main method. Okay, remember the variable scopes that we saw in last class? Okay, and I'm gonna do the same thing here, but now I'm not going to give it any new keyword. Okay, leave it this way. Okay, now I'm going to create another string, call it name, and then I'm gonna say Java inside. Okay, don't forget the semicolon at the end. Okay, that's very important. And then I'm going to just create another string, and I'm going to say another name, and then I'm going to give it a value of null. Okay. Now, what I'm going to say, I'm going to start printing all these guys. Okay. So I'm going to start printing sys out, right? I'm print my first object. Okay. Okay. So I'm going to say my object, which is this one. Okay. This one, my object. And then I just leave a space here, and I say my object. Okay. Remember, this is a global variable. It's a static variable that can be called from a static method, and that can be accessed from any part of the class. Okay. Now I'm going to print the other one. Okay. So I'm going to say my other object. And now I'm going to say my other object, which is this one here. You see how it changed the color? Before I created it, it didn't have any color here. It was just gray. Great. So when I just use that variable, it becomes white. Okay, good. So I have that. Now I'm going to print my local object. So I'm going to say my local object equals, which is this one. Okay, my local object. And then I'm going to say my local object. Okay, then it becomes white, right? Continue. Okay. Now, what happens if I do this? Another local object. So what do you think is going to happen there? What do you think? What did we say about local variables last time? If you're typing this in your computer, just hover over this, and it's going to give you an error. It says variable another local object might not have been initialized. So remember that when you have a variable inside a block, it has to be initialized. So now if I do this, then it disappears. Okay, you have another problem. Not another problem, another warning, but it's not an error. Okay, if I do this, if I run it right now, well, actually, I'm going to get an exception. It says Java variable another local object might not have been initialized. So this is a timer, a runtime error. Okay, so this guy does not compile. Okay, so we say this does not compile because the variable my local object is not initialized. Okay, don't forget that the variables that are in a block, they have to be initialized. These guys, they don't, because they're static. They're outside this main method. Okay, outside a block. They're just a class member field. Okay, good. So now let's continue. So we say sys out, and now we're going to print the name. So we say name, and the name. We close here. So we print the name. We see sys out again, and this name is this name, right? This one here. Now we print another name. We say another name, and then we just give the variable another name. Okay, and it's gonna give me a warning. It's always null. That's okay. We're gonna print it anyway because we initialize it to null. So we assign null to this variable. Okay. Now we continue. I'm gonna say now my string. Remember that I created this, but I didn't give it any value. I'm gonna do it now. So my string, and now I'm gonna say Java. Okay. Now I'm gonna print my string, right? And I'm gonna say equals my string, right? And now I'm gonna do something here. I'm gonna say my string, and then I'm gonna call a method that a string has. So we're gonna say to lowercase. Okay, good. So now I'm gonna print my string again. My string. Okay. That's it. Let's print it. Let's see what we get here. So we're printing, before we print, we cannot print this guy unless we initialize it. So otherwise we get an error. Okay. Here we are declaring this variable name, Java, and we create another string variable and we assign null to it. Okay. So we're printing my object, that is this one here that I created, right? We are printing the other one that it doesn't, it's not an object completely created. And then we have this string here, right? We just give it a value because here we just declared it, but we didn't assign it a value. Okay. Now, after we print that variable, that my string variable, we just try to lowercase, just to print all lowercase, and then we print it again. Okay. So let's run it. Let's see what happens. So if we run it, right, we start getting some things here, right? So the first, let me just probably give a space here before start printing. Let me just say this is the first print, right? This out. Okay. Let's see what happens now. A moment. So we can see better now. Good. Okay. Guys, why do you think we're printing this guy? Why do you think you're printing this? Do you have an idea of why it prints java.land, that object here?
You're just printing the object.
The what?
Putting the object instead of a string representation.
Yeah, you're just printing a reference, right? You're not printing nothing. There's nothing there. You're just creating an object here, but you haven't assigned any value to that object. Okay? You're just printing a reference to the object. You know, when you create an object and a memory, just an address in memory is allocated for that object, but there's no value in it. So you're just printing the location.
So is it printing the allocation in memory? What is that number that it has there?
It's a reference. It's just a reference memory of that object.
So the reference in memory, right?
That's right. So
okay.
Here is printing name, you see? Because name has a value. We give it a value here, right? But here, we're not giving it a value, we're just creating an object, right? Mm-hmm. Now, when an object is not giving a value, by default, it gets a null. Mm-hmm. Okay? That's by default. You're going to be tested that in exam. They're going to put some static variables, and then you have to do what it defaults to. Remember last time that we're printing a lot of primitives. Let me see which one was that. Primitives static variables code. Okay, let me see if this one. No, that's not the one.
It's the one with Boolean.
The one
We'll
Boolean.
go down
Char Boolean.
char, yeah,
Okay.
char and Boolean.
That's not the one. Variable scope, probably that one. See? Not that one either. I didn't delete that.
I think you made changes to it. That's why it's not printing null.
Okay, this one, default is the initialization. All right, this is the one. You see how you have to memorize these guys. You see the Boolean defaults to false. My byte to 0, my short to 0, my int to 0, my long to 0, my float to 0.0, my my double to 0.0, and my, let me open that, my char defaults to this one. Okay, guys, don't forget that. That's very important. And then my object defaults to null. Okay, my object defaults to null. Okay, let me just print this. As you see here, it defaults to null. Okay, now strings, they have a null here, they accept a null. Okay, now this another local object, it didn't print anything, right? Because it is not initialized, but this one defaults to this strange number here. It's the same as this one, okay? Because we're not printing an attribute or a field of an object. We're just printing the object, which doesn't make sense to a human because it's a weird number, a weird print here, okay? So whenever you print an object, you're gonna get this. You have to print an object method or an object property. So you see here, my string is a class, and a class has this, the string class has this method. So you have to do something like this, okay? If you have my object, you should something like this. You see, those are methods and things that the object class has. Then when you print that or something that the object has, then you get something specifically. But in this case, you're getting the reference to the object, not a value. Okay? Now, something interesting here. Something interesting. Why, if I lowering this to lowercase, just bring it to lowercase, why am I getting the same value? You see the same value here? Even when I change it to lowercase and I print it again, I'm getting this. Do you have an idea why, guys?
It's mutable streams.
Who said that? Who said that?
That was me. I'll say.
Say, good, because strings are immutable in Java. You're gonna change a string just like that. You will have to do something. You will have to do a workaround. Guys, see this. The only way, because what happens? When you do this, you return another string. When you're doing this like that lowercase, you're returning another string, but you're not saving the other string in a variable. You're just printing the same thing. Now, if you do this, just take a look at this. You see? And now we do new string. And you print it. What do we get? Lowercase. That's very important for you to understand, guys. In Java, strings are immutable. It means that they will not change unless you put it in a variable, because it returns a different string. Okay? Here, you return a different string, but if you take a look at this, it tells you result of a string case is ignored. It would not do anything. It would just print the same thing. Okay? It would just print the same here, nothing new. This will be ignored because strings are immutable in Java. Okay? So you have to put it in another string and then store it there, and then you can print a new string. Right? It's like this. If I do this, what do you think is going to happen? What do you think is going to happen?
Same thing.
The same thing. Nothing's going to change. But what if I do this? And then I print upper string. What do you think? You see? Do you understand that concept, guys? This is returning a new string, but you're not storing anywhere. That's why you're getting the same result. You have to store it in another variable to be able to print a different string. Okay. So let me put it here. This result. The result of this is ignore. Okay. Okay. Don't forget that string is a class. That's why string has so many methods. Okay. If I take a look at upper string here, upper string, and I just hit the dot, I'm gonna see that it has lowercase to lowercase with locally equals get char substring char at length. Okay. If I do length, what do you think is gonna happen? What do you think is gonna happen here? What do you think is gonna print here? What do you think it's going to print here? Guys, it's not going to print anything because strings are immutable. You know, it says here result is ignore. So if I click here, I don't get anything. Okay, but if I do int, because the length is a number, right? 1, 2, 3, 4, 5. That's the length of the string. By the way, a string is an array too. It's an array of characters. So if I say length, and I say, if I say the length of upper string is len. So let's see what happens. Okay. So what do we do now? We get 4. You see there? The length of Java is 4. Okay? Because if you count, you have 1, 2, 3, 4. Okay? You have 4 characters, so that's the length. Got it? So as strings are immutable, I say that again, right? You have to store in a different variable because it's returning a different value, and that number is 4. All right? You're not changing anything here. You're just getting the length of that. Okay. Good. When we see string builder, the string builder class, that one is not immutable. So that one you can change it, but that's a different thing. It's not string. It's a string builder. Okay. So this returns 4. Okay. This returns Java. And this returns okay. Got it, guys? Do you have any questions? No questions whatsoever? This returns null. Okay. This returns this. And this returns. Okay, it might be a little different for you guys because you have a different computer, you have a different system, right? But so based on your PC, right? Okay. Understanding nulls. Okay. Don't forget that by default, this returns an address in memory, like a reference in memory. This returns null. And this one returns null as well. But we are assigning here a variable, a value, which is Java. Okay? Very important. So let me see. This does not return anything because strings are immutable in Java. Okay. Got it? And the result of this is ignored. Okay. Good. Any questions before we go to the next topic? No? Okay, good. So let's continue. I'm going to talk about wrapper types. All right. So now wrapper, another class in the same package, wrapper types. Okay. And you will understand what wrapper types are. For example, you have these here. Let me see here. You have like integer. That's for int, right? Double. That's for double. Okay. Floats. That's for floats. You see, with uppercase, you know, like the word and then int, double, and double, float, float. These are classes, okay? These are primitives types, and these are classes, okay? They have methods and things like that, just like a string class, okay? So I'm gonna create this guy, the one that we always create, okay? And then I'm gonna create an integer. So you know, guys, how to create an integer. So I say my int, and then I'm gonna say just give it a value of 10. All right. So I'm gonna create now a wrapper class, right? And I'm gonna say my integer, and then that's gonna be 10. And as you can see, it has the same result here. But this is a primitive and this is a class, okay? And it's called a wrapper class, okay? And of course, but it's a type too. Whatever you put before the variable is a type, whether it is a primitive type or a class type, okay? So now I'm going to create another integer, and I'm gonna say my integer 2. And I'm gonna say 20, okay? And now I'm going to get another integer and call it my integer 3. And I'm going to say integer As it is a class, it has methods. Okay, so I'm gonna say value of and then I'm gonna say 10. Okay, and then we get a warning here, unnecessary boxing integer, but this is, it doesn't matter if we get this, it's not necessary. I just explaining to you that there are different ways to say the same thing. This is the same as equals 10. So my integer 3 is the same thing. Okay, there's even another way to do it, and it's integer using the class integer. Okay, and we say my integer 4, and we can say integer, and then we say parse int, and then we say 3. So what are we doing here? Guys, what is this? Can you tell me what this is?
Converting a string to int.
Yeah, this is a string. Guys, whenever you see between quotation marks, that's a string. Okay, but what type is this? What is this type? An integer, right? So we cannot store a string in an integer. So this doesn't make sense. You get an error. That doesn't make sense, right? Right? So we have to parse it. We have to do something like this. And then we put it inside this, and then that makes sense now. We are parsing that. Now, if we do system sysout and we print num, what do you think we're gonna get? So we get, if we just run it, we get number 3. We're passing a string that has a number inside, but still is a text because it has quotation here. But we have to parse it. When you say parse, is convert. We have to convert from string to an integer. That's why we use this method parse int that the integer class has. And then we put inside the text, and we pass that text to this here, okay, to this method, and then it converts it to a number. Okay. Okay. So now let me do another one. Integer, my integer 5, and then we say null. Okay, perfect. Can we do this? Integer, my int2 equals null. Can we do that? No, we can't, because the primitive int doesn't have a null. Okay, we initialize the 0, right? That's the default value, as we learned before. The default value is 0, okay, or 4, or 7, you know, a value, but never null, because the one that has a null is the wrapper class integer. Okay, so this does not compile. Okay, so this does not compile. Okay, this is correct, but comment it out. Okay, same thing here. Actually, I'll do this. All right, this is correct, but it's commented out. Okay, now we continue. Let's print each number here. Okay, let's print this. So we say sysout, and then we say my integer.
What was that shortcut?
Sysout.
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 Oh, you just type sysout in. Oh, okay.
Sysout. What could the same with the main method? You say public static void main. Public static. Yeah, it's not letting me because I'm outside that, inside the method. Public static. and then you just click enter. Okay. It doesn't let me here because remember, methods cannot overlap. If I create a method inside a method, it would not give me that choice. You see?
Right.
Good. Let me print that. This out and let's say my integer, which is the first one here, my integer. And then we say equals and then say my integer. My integer. Okay. Now I'm gonna copy this guy so I can, let me copy this guy so I can just reproduce it. Okay. Right. All right, so the second one is my integer 1, 2, right? My integer 2. So I'm just close this guy and then enter. And I put here my integer 2. Okay. Now I put my integer 3. And then I close this.
You need a second semicolon on the second line, yeah.
Yeah. Okay. So now I have number 4, number 5, right? So see number 4 here, number 4, and then number 5 here. Oh my God. Number 5. Right? And now I am good. Okay. I am good here. So I can just print this. Let's see what happens. Okay. So we're getting this. My integer is 10. My integer 2 is 20. My integer 3 is 10. My integer 4 is 3. And my integer 5 is null. So exactly what we see here. Okay. All right. A bunch of warnings here, but guys, don't worry about that. Okay. You just have to know that there are different ways to declare a variable, an integer variable in Java. Using this way, using the wrapper class, because this is another way. Okay. But just using the wrapper class. So this way, this way, this way, and this way. Okay. So basically, we can say that these 3 are the same if I do this. Okay. See? Well, let me do this. 6. I can have the same name. Otherwise, I'm going to have this issue here. Okay. So if now I print, okay, I say sysout, and I say three different ways, still same result. Right? Nice. So I can say, let me put these guys here, bring these guys here, and just put them here, and see 6, 7, 8, 6, 7, and 8. Now, if I print that, I get this. I get the same results. So there's 3 different ways to do this. All right. Got it? So let me do something here. Scanner.
I'm confused by 1.
I'm sorry?
I am confused by one of them.
Which one?
Integer, my integer 5 equal null.
Oh, this is initialization. You're not giving it any value. The default value.
I cannot do that with an int. So why is it? Because integer is a class?
Yeah, it's a class. It's a wrapper class.
Okay, I see.
This is a primitive. Okay.
Uh-huh.
A primitive. Okay, so let me do something here. Let me do scanner equals new scanner. And then put here system at in. Okay, and then close this. We have to import the class scanner. I think it is imported already. It's imported here. So it's a good thing that IntelliJ has, that it imports the classes automatically. Okay, so I can say system now, enter a number. And then I can say number, integer number, input, next int. This is out number. So enter a number. All right. It's a good thing that they fixed this, because before you have to parse that number. Why? Because because not in Java but in C#, you have to parse this, because by default what you enter is an integer, is a string like this. So it receives a string, then you have to parse it. Okay, you have to parse it.
In JavaScript too.
I'm sorry.
It's like that in JavaScript when you do the console.
Yeah. What you enter by default, that number that you enter here, it is a string. So you have to parse it when you get it, but you don't need that in Java. Okay. So in another language, for example, you have to do this, like integer, parse, and then put something like input that next something like that, next line, something like that. Okay. Let me see now. There you go. You see, something like that. You have to parse it. It's the same thing, but thank God.
Can you put it in quotes can you run it again and put it in quotes? Any number in quotes?
But
double quotes?
If I put it in quotes, I'm hard coding the value. This is not hard coding.
No here. No.
Where?
Can you run it again? And when it says enter a number, they put run it.
Okay. You may get a
double quote.
You may get a
number and then double quote.
Get an exception. Number format exception. Because you are there is expecting a number.
So look what it's doing. Look.
What? It's expecting a number. You're entering a string, right? So it's a format error exception. Okay. You're supposed to enter, and then you can have an if statement there just in case you put the number into quotation marks. Then you catch that exception. You catch it, and then the program doesn't crash like this. What happens now? This is a very undesirable outcome. You don't want the program to crash. So you have to have some sort of handling, exception handling in place to be able to just keep the program running. Probably would say run entry, please try it again. And you don't crash, the program doesn't crash. Okay? So these two, they accomplish the same thing. Okay? Right? So if I just run it and I put 10, I just get the same thing. Okay? So probably you want to say, what is your age? Okay? You say if age is greater than 20, no. So if you have to have this, right? And then you can say if age is greater than 20. Well, actually, I can put it in the same line. If it is only one line, I can say this out. Wow, so young. And then if you say, or actually not greater than 20, maybe
Less than 20.
less than 30. And then we say else, and then we say this out. Still young. Okay. And then I can put this here. Right. So now if I run it, 35, still young. Run it again. And I say 24. Wow, so young. Okay. So we're just speaking English here, guys. Speaking English. If the age is less than 30, then print wow, so young. Else, print still young. Okay? And why am I using the same line? Why I'm not using this guy here, like a block? Because if it is more than one line, so this will work, right? This will work because it's only one line. If I do this, okay, something that you have to probably know in Java is that if you have only one line, you don't need curly braces, okay? You don't need this, okay? Because it's only one line. Now, if you have more than one line and you want everything to be printed, then you have to put curly braces, okay? Otherwise, if you do this, right? It will give you a problem here because there shouldn't be another statement between the if and the else. This is a very common error, a very common mistake that people make, and also they put it in the exam to test you. There cannot be a statement between the if and the else. There can't be. To solve the problem, you will have to put this guy here, and then it will disappear. Okay? There cannot be any statement between the else and the if. That's why it'll tell you this. It tells you that there's no if statement. Else is without if. Okay? Now, if I remove this guy, it works because it's only one line. Okay? Got it? You understand it, guys?
Yep.
Yes, no, maybe, perhaps
Yes,
tomorrow.
yes.
Okay. Now let's do something else. Let's continue here. Okay. So let's just take a look at this converting a wrapper class. Okay, wrapper. To primitive. Okay, and that's what is called in Java unboxing. Okay, it's converting a wrapper to a primitive. Unboxing. Okay, so don't forget that term, unboxing. Okay, so this is it. Remember our integer, just the way you do it, integer 3. Okay, we're declaring that. And then we want to assign my integer 3. Okay, so we are converting from wrapper to a primitive. Okay, now if I print this, I'm gonna get whatever value was in integer 3. Okay, 10. Okay, so this is called in Java unboxing. Converting a wrapper to a primitive. Okay, very important that you remember that concept. Converting a wrapper to a primitive. That's unboxing. Okay, so now what would happen if I do this, guys? int 4, my integer 5. What happens there? Let me know. Why am I getting that error? Why am I getting
You're
that error?
getting an error because
Null.
an int cannot be a null.
Correct. So we have a null value here. So you cannot assign null to an integer, to a primitive. So we have here null pointer exception. Okay, so this throws a null pointer exception. Okay, this will throw a null pointer exception. Okay, primitives cannot contain null. Okay, so I just put nil because in Ruby null is nil. Okay, so throw a null pointer exception, primitives cannot contain null. So it's very important that you guys be careful in the test. Just look around, search for the different values, and see that they're trying to catch you. Okay, now boxing. What is boxing? Boxing is just the opposite, converting a primitive to a wrapper. Okay, for example, this one, and I think that we already saw it. Okay, integer 9, my integer 9, and then we say new integer, and then we get a value, we say 10. Okay, so this is not necessary. Okay, so there's not a boxing new integer, but just to tell you guys, to show you boxing, how it happens is converting a primitive to a wrapper. Or we can do this one, my integer 10, and we can say my int. Okay, so we're assigning a value that is here. We're assigning 10 to a wrapper class. Okay, so we're doing the opposite, the inverse process. Here we're assigning a wrapper to a primitive, and here we're assigning a primitive to a wrapper. Okay, this is called boxing, and this is called unboxing. Okay, now let me create a method here, and it has to be outside the main method. Okay, like we learned before. Let me just format this, and let me make it here. I'd say private. Does it make it private? Okay, private static void, and let me call it print sum. Print sum. Okay. All right. Perfect. 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 What are you thinking we're going to do here? We are printing the sum of two numbers. Okay. We're printing the sum of two numbers. I decided to make it private because we only accessing this from this class. We're not creating any other class to access this print sum method. If we are trying to get access to this guy from another class, then we have to make it public. Okay, good. So let me just pass two variable here, two values, and I'm gonna say integer first, and then integer second. Okay, we're just passing two values. Perfect. Right? So far, so good.
Yep.
Okay. So now we're gonna say, very simple, straightforward. Create a variable, name sum, with this type, integer, right? And we're just adding first plus second. Okay? We're just adding these two numbers here. They don't have any value yet because we haven't called the method yet. We're gonna call the method and pass these two values. Okay, good. So now I'm gonna do sysout, and I'm going to print and say sum equals, and then we just put the variable sum. Okay, perfect. So we just created a method that calculates the sum of two numbers. Now here, we're going to call the method, right? And we have to pass two numbers because whatever I pass here, it has to match this signature. Okay, it has to match the signature of the method. It has to match the name and the parameters inside. Okay, so I'm gonna pass 1 and 5. Okay. Okay. Now what do you think is gonna happen? It's gonna calculate 1 and 5, and it's gonna return 6. Now, what is happening here, guys? This is called autoboxing. Why? Because we're not assigning anything. We're not doing unboxing. We're not doing boxing. It automatically is assigning an integer to a class wrapper by coming here and assign it. And Java is smart enough to get this number and use it as a wrapper. Okay. Now, if we just print this, what are we gonna get? Let me put this part. The sum is 6. Okay, good. Now, for you to see how autoboxing works, let me call this, and right now, let me pass my integer and my integer 2. What I'm passing now, I'm not passing. Let me just comment out this guy here because I don't want this to be interrupting the flow of my good. And let me just comment this guy here, and it will just remove the import that I have here. Okay, pretty smart, huh? So now let me run this, and we get what? What do we get here? 30, which is the sum of 10 and 20. Now, what happened here, guys? I passed a primitive 1 and 5, and I passed two wrapper classes here. And you see how it can, well, actually this one will match exactly this one because these are integers too, but these are integers. Let me make it even more visible for you guys. Let's say num1 equals 10. You see 1. And int, sorry, num2 equals 5, right? Let me eliminate this guy. Okay. And now instead of passing 1 and 5, I'm going to pass num1 and num2. Okay. So these are integers, right? And we saw that before, that you can assign an integer to a wrapper. That's what we're doing here. So we're just running this, and then we're getting 6 and 30. That's autoboxing. Here, we're doing it on purpose. We're just assigning this guy to this, and then that's boxing, and then we're assigning this guy to this is unboxing. But autoboxing, right? Autoboxing is just automatically, it takes these two integers, are two primitive types, and assign them to these guys here, the R wrappers. Okay? Guys, do you understand this? Boxing, unboxing, autoboxing? Yes? No?
Yes, yes,
I'm
yes,
lost.
yes. Yes.
The question I would have is, when would you use one over the other?
One over the other is just a matter of choice. It's when you're assigning something to something. Okay? If you're assigning this guy to this guy, is unboxing. If you're assigning this guy to this guy, is boxing. It's not something that you use. It's something that happens when you assign one wrapper to a primitive type or one primitive type to a wrapper. Is that what happens behind the scenes? And that's why they call it unboxing and boxing. All right. Now, remember that this guy is a wrapper, so a wrapper has more access to more methods than an integer. An integer doesn't have anything. If I just do say this here, int 3, you see, it's just a few of them, almost nothing. But if I do this, my integer 10, right? You see how many things do we have here? Because this is a class. Okay, that's the great advantage over primitive. That's a class. So this is an object of this class. And you can have access to a lot of methods through the object. Okay, through the object of that class. So basically, what we're doing here is instantiating this class. If you know about object-oriented programming, you know that an object is an instance of a class. So for example, if you do string name, right? Name is an instance of a class because string is a class. So if I do name, look how many methods do we get? Because integer and strings are classes. And the color is telling you everything. A class has a blue color, and a primitive or any other type has a red color. You see? That's the big advantage of classes over primitives. Does that answer your question? Whoever asked, did he answer your question? Yes, no, maybe?
No.
Who asked the question about when do I use one over the other? Who was that? Aussie, Neil, Michael, Kevin, James? Who was that? Okay. All right. So guys, do you have any questions about this?
No, well explained. Thank you.
Okay. So again, you have a bunch of methods to access. Remember that when I create I think it was in the person class. When did I, in the main class? Remember that I created, where did I create? Test person. Remember this, when I create an object, you see the object here? Okay. Object. Does it look familiar? Does it look familiar? Similar. Okay. Similar. Okay, you're creating objects, right? So this is practically unnecessary. Okay, you see here, this is not necessary. Why? Because we can simply say this, and that's it, right? So this is unnecessary. Okay, so this looks like this. So we're getting the class person, which I have here, you see here, and then I'm creating an object of that class. So this person one is an instance of this class person. So if I just hit person one and I click this, and I get access to all the methods of that class. The same happens with the integer wrapper. Okay, if I do my integer 10, right? I get access to a bunch of methods here, more than remember the regular int got this guys here. I get more. I get a lot of resources here. With just the int, right? I just get a bunch of poor methods here and things here. Okay, not much. You see, I can do that easily. Okay, good. So we still continue. Okay, now let's talk about arithmetic operators. So this is a little confusing what comes now, because in the exam, you have to think like a computer. And literally, guys, I'm telling you, you have to think like a computer. Okay? So my advice to you is do not take the exam at home if you want to pass this exam. Not highly recommend it unless you are a machine. If you're a machine, you're more than welcome to take it. Last time I checked, I'm not a machine, so I would not do that. Okay? So let's do this. Integer result, int result, right? And I'm gonna say 3 minus 2 plus 2 multiplied by 2 plus 3. Beautiful. So what do you think about that? It's very important here that, guys, you understand the precedence of operators. Okay? You know that the first one is multiplication, after that division, and after that sum, addition, and then subtraction. You have to remember that. Okay? Very important that you remember this. What do you think that this is gonna print? What do you think?
Gonna be 8. 8.
Does everyone agree? Guys, do you agree?
Yes.
Okay, let's check.
No.
And Maria's right. Okay, so the first time you have
2 times 4.
minus 2, and then we have plus 4, right? And then plus 3. Okay, because it's going to first multiply these two guys here, and then you get 4. Okay, now the second time around, you get 1 plus 4 minus, or mass, sorry, not minus,
Plus 3.
plus 3, right? And of course, when you do this, you're gonna get 5 plus 3, because remember, this is from left to right all the time, from left to right, okay? And then you get 8, okay? So you're gonna get those guys. Okay? So you see how it works? First this, then it will do the sum, right? And then it will do everything from left to right. So 3 minus 1, and then plus 4 plus 3, that will be 8. Okay, let's have another one. So right now, we just print here the way it's supposed to be. Result equals this. Okay. So more beautiful. So we print this, and then we get result equals 8. Perfect, beautiful here, right here. Okay. Now I think that you can see it better, guys. If I do this, then you can see it here, right? It's much better if you see it here, right? It's better for you guys, right? Good. Let me have the other one. Result, just I'm gonna reassign that. As a result, I'm gonna say this: 4 divided by 2 plus 1 minus 4 multiplied by 2 plus 10. So what do we get here?
does anyone everybody have Python installed on the computer? And
5.
conduct.
Does anyone agree? Does everyone agree?
Yes.
5. So let's print that. So let's say this guy here. Okay, let's put it here. So now we get
15.
because equals 5. Equals 5. So what do we do here? So the first time that it comes, remember, is from left to right. It says 2 plus 1 minus 8, because it multiplies this guy, right? And then plus 10. Okay, plus 10. Now the second time, when it comes, it says 3, because remember, is from left to right. 3 minus 8 plus 10. Then you just see minus 5 plus 10, and then you get 5. Okay, that's the way that the computer thinks. Okay, from left to right, and then respecting the precedence of the different operations. Okay, let me have another one. Okay, watch with this one, be careful. Int a equals 4, right? And then we have int b equals 3 minus 2 multiplied by minus a, this. Okay, so what's happening here? This is a decrement, then use. Okay, so minus 1 is the same as a equals a minus 1. It's the same thing. Okay, so this is something that is used in programming. Decrementing or incrementing. Decrementing would be like this. Incrementing is like this. Decrementing, sorry. So for those guys who have some knowledge on programming and decremented and incremented, so what do you think would be the answer to this?
Minus 3.
3.
So
Minus 3.
Minus 3.
Minus 3.
okay, what we're trying to get here is the value of A and B. We're not trying to do any calculation here. I mean, calculation for B, but we're trying to print. So we're using this, we're just putting this, and we're saying A equals A, sorry. Oh my God. A, and then B equals B. So what's going to be the value for each variable?
So it's 4, and B is minus 3.
You think so?
No, that's
3 and
Let's-
minus 3.
that makes
maybe
sense.
3. Yeah, because you're decreasing it.
That makes sense. So let's see it.
Okay.
3 and minus 3.
I don't
Okay.
see the bottom of the screen.
So-
What the heck is going on with my screen?
So now we have this first, we have 3 minus 2 multiplied by 3, because A was 4 and now it's being decremented to 3. Okay, remember, when we have something, guys, that you have to understand, when we have minus A is decrement and then use. Okay, when you have A minus, it means use and then decrement. Okay, it's the opposite. Okay, so, and of course it's going to do the same thing. Okay, now here we have the first time around, we say 3 minus 2 multiplied by 3, right? And that's going to be 3 minus 6, right? And we're just calculating B. Okay, And now we say that B will be -3, and A will be 3, because remember that here we just decrement A. Remember here? 4 minus A. And then finally, A is going to be 3 and B -3. So that's very important, guys. Now you take a look at this and you understand this. We're going to see more exercises of this, okay? This is not the only one. You have to get really, 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 skillful with this, guys, because they're going to be in the exam all the time, and they're going to make it more complicated than this, okay? And the part that is concerning is that you have to do that mentally, okay? And you don't have a computer for that, okay? So that's why it's highly recommended to use a piece of paper to be able to decrement that with a piece of paper, okay? Let's do another one, okay? So let's do this one. A equals 4. I don't have to say int A again because I already have it here. So I'm just reassigning a value. And B is going to be 3 minus 2 multiplied by A minus minus. So be careful with this one. Okay? Be careful with this one. So I can tell you that this is use and then decrement. Okay? A equals A minus 1. Okay? So what do you think is going to be the result of B? So can I do the same thing here?
4. No. -5.
-5 for B?
Yes.
And for A? And for A?
3.
3.
Let's print it. There you go. There you go. So let's see it. Okay. So the first time we have 3 minus 2, and then multiply by 4, right? Because remember, it's use and then decrement. So we haven't decremented anything. We're just using A, which is 4. Okay. Here we decrement and then use. So here is 3. You see the operation here first before the letter, the A variable. So you decrement first and then you use it. Here you use it and then you decrement. So the second time that we're going to see this is 3 minus 8, right? And then we're going to have -5. So B is going to be -5. And A is going to be 3. Okay?
I need a break.
You need a break? I think it's time for a break, right?
Yeah,
Yes.
yeah.
Let's have a 10 minutes break and let's meet.
Okay.
Thank you. Okay, guys, we continue. So now we're gonna have another one. We're gonna say long C. Remember, the long is a primitive. Okay, we're gonna say long C, and then we're gonna give it a value of 2, right? And now we're gonna say long D, right? And we're gonna say 4 plus 3 multiplied by C plus plus. Okay, so remember, this is use and then increment. Okay, so what do you think is it going to be the value for this? This is same as C plus 1. All right, so what do you think is going to be the value for this?
C is 5. C. C will be 3 and D will be 10.
What do you think? Guys, what do you think?
Yes.
Okay, let's just run it. C is 3 and D is 10. Perfect. Okay.
Yeah.
So we are good. We are saying the first time we're saying 4 plus 3 multiplied by 2. Okay, because we're using and then incrementing. Then we say 4 plus, say plus 6, and then we get that D equals 10, and then C, we're incrementing that after we use it, so C is going to be 3. And that's why we get here C equals 3 and D equals 10. Okay, pretty good. That's the analysis that you have to do in the exam. Okay, pretty good. So now we continue. We have another one. Okay, this is doesn't stop. Okay, so we get a result. We are reassigning a value to result. We already have result declared before, so we just assign a value. So 10 minus 3, and then multiply by parentheses. We say 2 plus 1. 2 plus 1. And then we say minus 4 divided by parentheses 1 plus 3. Okay? Remember, the parentheses, they have precedence over anything else. Okay? That's very important. So let's print the results. Okay? So guys, in the meantime, just analyze this and tell me what the result is.
Zero.
It's 0.
Wow. Good. So let's print it. Let's see what we get. 0. Good. Very good. So what's happening here? We're saying 10 minus 3 multiplied by 3, right? Because we're saying 2 plus 1, that will be 3. And then we say minus 4 divided by 4, right? So we're saying that the first time. Second time, we have 10 minus 9 minus 1, okay? And that's going to be 10 minus 10, right? So result equals 10.
Zero. 0.
I'm sorry, not 0.
It's okay. Too late in the day.
Okay, so yeah, I had a class from 9 to 5, so that's a lot. All right.
Mhm.
So we get another one. We have this guy here. Okay. We say int I equals 10, and then int j equals 3. Right? And now we say that int k equals I modulus j. Okay? So modulus, what happens with modulus? You get
Rest.
the remainder. Okay?
The remainder, yeah.
Basically the remainder of the division of 3 by 10 by 3. The remainder is the value here. Okay? So right off the bat, if you think about that, every single odd number has a remainder 1. And every single even number has a remainder 0. That's something that you have to know as soon as you see this. Okay? So this, if we print k, what are we going to get? See this out?
1.
K. So if we print it, we see that we get number 1.
1.
So we say here that remainder of division between I and j is k. So we get this now. Remainder division between 10 and 3 is 1. Perfect. Okay. So how do we calculate this? Okay. In the United States, they have a little different system as in Cuba, but I'll try to do my best here. So we have here 10 divided by 3, right? So we get, okay, 10 modulus 3 is the same as 10 divided by 3. And then what do we get? 3. That's the first time that we do it, right? Now, we're going to say 3 multiplied by 3, you see? What do we get? 9. And then that 9 is going to be subtracted by 10, from 10, I'm sorry. And then we get 1. Something like this, right? So we get 3 divided by 3 to get 3, then you multiply 3 by 3, okay? Which is the remainder and the dividend. Dividend, is that what you call it? And then that equals 9, and then you subtract 9 from 10, and then you get 1. Okay? But, like I said, right off the bat, it's an odd number. What do we get? 1. So what do you think we're going to get if we do this? Int e equals 10 divided by 2. So what do you think is going to be the value of e?
Zero.
Okay, why? Because
0. Mhm.
because 10 is an even number. Okay, but 10 divided by 3, that's not an even number, right? So we get this, and then 2. So the result is 0. So what do you think is going to be the result of this? And let's say L equals 12 modulus, what is this? Okay, modulus 5.
2. 2.
What do you think?
Is this the one? No.
L will,
Yeah,
L will
I
be
got
2, and then E will be 0.
You see, you get 2. Remember, this is the remainder. Okay,
The 2
remainder.
divided by 5 is 2 times 5 is 10. 12
And then you get
minus
remainder
10
2.
equals 2.
And then you get
Right,
remainder,
remainder 2, right.
right?
Yeah.
Good. And what do you think is going to be the result of this?
That will be 1. Remainder M,
Yeah, that will
M
be
equals 1.
Because 13 is an odd number.
Right.
Okay, so we get 1 again. Okay, so it's very easy to find the odd numbers and the even numbers by just saying scanner input equals new scanner, right? So system, guys, this is to get input from the user. Okay, so we say sys out, enter a number. Okay, now we say num, int num equals input. Input is an object of the class scanner, and then next int because we are getting an integer, right? Our input is an integer. We say if num divided by 2, right? The remainder equals 0. Then sys out num is even, right? Else num is odd, right? When it's even, the remainder is 0. When it's odd, the remainder is 1. So if you do this, okay, enter a number, 5, odd. Enter a number, 4 is even. You see? This will give you the modulus, which is the remainder of the division. Okay? Don't forget that. Very important. Okay? Let's have another one. Okay? A little more complicated, guys. A little more complicated. Okay? So let's see what you get with this. Okay? So we have int f equals 12, int g equals 5, int h equals 2. Okay? And now int n equals f divided by 2 minus 10 modulus 4 plus 3 minus 2 multiplied by f modulus g minus h multiplied by 3. That's a good one. Right? So let's get the result of n. Okay? So we can say that get a piece of paper if you need it. Piece of paper. And let's find that. Don't forget that with the ones in parentheses, they have the precedence. Okay.
-9.
-9. Let's wait for the other guys to finish. So I'm gonna post this on Slack. I'm gonna put it here. This is the Java operator a precedence table.
I get -7.
Anyone
Me
else?
too. Me too.
Anyone else?
I got -19.
Wow. So let's see it. Okay, I'm gonna have this guy here. -7 is the result. N equals -7.
Uh-huh.
Okay. So let's see here. First time around, so you get divided by 2, right? 12 divided by 2, and then -10, and then modulo 7. Modulo 7, because 4 per 3 is 7. And then you get -2, and then multiply by 12, modulus 5, -2, multiply by 3. Okay, so 5 was just substituting variables. Okay, and at the same time we just calculated this guy, which is the first one that you have to do.
Right.
Okay, so next time we got 6, because you start going from right to left, right? From left to right, I'm sorry. You get 6 -3. Okay, remember that the modulus of this guy here, the remainder is 3. Okay, -3 -24, because you have 2 multiplied by 12, that's 24. And then you get modulus 5 -6, because you have to multiply these guys. Okay? That's the other time that you come here, we have 6 -3 -4 -6. Okay?
Right.
Because we get this guy here, and then the modulus 24, 5 is 4. Okay? Because you multiply 4 by 5, and they subtract 20 from 24, the remaining is 4.
Oh, Maria, how can you make such a
Okay.
simple mistake?
So now we have -1 -6, and then when you have minus, you sum, you add, and then you keep the same symbol, minus. That's what you get, -7.
Mm-hmm.
Okay. So don't forget the table of precedence here on Slack. Remember that first is multiplication. First multiplication, then division, and then modulus. Okay. Very important. Very important. All right. Good. Continue. Good, huh? Good stuff, man.
Yep.
Yeah, we're done with this part.
Yes.
We're done with this part. Okay. It's a long exercise here. Very long. But at least we can have a better idea of the, operators, right? So let's see now something called numeric promotion. Okay, so let's create another class here, and let's call it numeric promotion. Okay, numeric promotion, and then we're gonna do PSVM, which is our dear friend May, to be able to run the program. Okay. Beautiful. So now, so what is promotion? Promotion is converting smaller to bigger type. Smaller to bigger type. Okay, so let's start. We're gonna understand this when we go as we go. Okay, so we say integer x equals 5, and then we say double y equals 10.55. Okay, 10.55. Okay, now what you think is going to happen here? You will say x plus y, and then we say equals, and then we say x plus y. What do you think is going to happen here?
$16.
I don't think it's going to add it.
Let's see it.
$510.
That's called
What? Where the heck did you get that from?
That's called concatenation.
Yes, like a string.
Everything. We have to do this.
This is a cat command.
So if you do that now, we get 15.55. It's called concatenation in Java or in any object programming language. It will bring everything together like it is a string instead of an addition of two numbers. Okay, so
That would be useful.
this will be incorrect. And believe me, I saw it in exam. They will put it this way to confuse you. Okay, so this will not give you the result that you want. That's going to give you returns 510.55. Okay?
Can you do the same thing with the string?
Now,
Can you say string this, string that, and then...
The string is the one that does it perfectly.
Oh, okay.
The string is the one that does it perfectly. Okay? So you can have this string name as a Dunieski, right? And if I do this, sysout name plus
X
double. Not that double.
plus Y?
X plus Y. You see? It concatenates everything. That's called concatenation. Okay? Concatenation. Right? Okay. So if we do this, double results equals X plus Y. Okay. And then we print, we sysout result. So what do we get? Same thing. You see? So you're basically, you have to put this guy to be able to get the result that you want. Okay? So you have to put it here or simply do this, right? And then you get that. Same thing. So we're going to get that several times. Same thing. You see? Because you're just printing, you're just doing the addition here, assigning it to a result variable, double variable, and then just calling, just referring to that variable here. And then returns the value that you get here. Okay. Now let's do something else. Let's continue, right? Now we're doing, and guys, why are we able to add an integer to a double? Because the answer is simple. There's promotion here. An int is promoted to a double automatically. That's why you can add X and a Y. Now, if I do float Z, and I can say maybe say float this, right? And now I can say this is out Z plus X. You see? We get the same thing because a float is bigger than an int. Okay? So it's promoted to that as well. Okay? So let's do another one. Let's say byte B. Remember that byte is the smallest of all the primitives. Okay? Byte n. And then we say int C equals 5. Double D equals 4.5. Remember that for the double, this is optional. The D, we don't need it. Okay? Now we say double result equals B plus C plus D. And of course, I already have the double result somewhere here. So what I have to do is just reassign it. Okay? So now we can do system assist out result equals result. Right? What do we get now? We get result 19.5. Why? Because all of these guys are promoted to a double. Okay, that's why you see this here. It's a promotion. It's just converting for smaller. A byte is smaller than a double, and an int is smaller than a double. Then it is converted to a bigger type. So that's promotion. Okay, that's why it's possible to have this calculation here. Okay. Now let's talk about casting. Guys, have you heard about casting? Casting is converting a bigger to a smaller type. Okay. So let's do something here. Double, my double, equals 5.55. Right? Perfect so far. Now, what happens if I do this? Int my int equals 4 plus my double. Can I do that? Your required type is an int, but the one that you provided is a double. You see here, I provided a double here. Okay? So we are in a bigger type here, and I am assigning a bigger type to a smaller type. So something called casting, we can do this int and problem solved. So we're casting, we are converting this number, this double, to an int, and then we can add int to an int because we are assigning it to a double, an int. But what if I do this? Do you think that's possible? You see, that's possible because we are just adding an integer and a double, and we are assigning to a double variable. Okay? This is all the way around. We're coming down. Okay? We're just coming down. That's why you have to cast it to an int. Okay? And casting is nothing else than converting. We're converting to an int. Okay? So now, if I sys out, I said result equals, and then we say my int. And then we get whatever we are trying to get here, number 9. Remember, why do we get number 9? Can someone tell me why we get number 9 and we don't get 9.55? Why?
Because it is integer, not floating number.
Correct. So we are changing this my double, which is 5.55, to an integer. An integer is a whole number. So it's just removing the decimal points and giving me 5. You want to see that? Let's do that. So I'm going to change this here and say int my double. Let's see what happens. Number 5. Okay? So number 5. Right? So you guys understand?
Yes.
Returns 5. And this one returns 19.5. I'm sorry, it returns 19.5. Well, actually, it returns 9, not 19.5. It returns 9. This is the number. Okay? It returns 9. Right there. So this returns 9. See? Okay, so we're moving down. We're coming from a bigger to a smaller. Here we're coming from a smaller to a bigger. Okay? Promotion. This is promotion, and this is casting. Okay? Now we have another one. We have int my, another int, and then we give it 125. Okay? And then we say byte my byte, and we say 15. Right? Now we say int result. I have already have the result, so I don't have to declare it again. We say result. Well, actually, let me get another name. Int result equals another int plus my byte. Okay. So that is possible, right? That is possible because we're going from a smaller to a bigger one. Okay. That is promotion. Okay. So now if I do this out, int result, I should get 140, which is 125 plus 15. Okay. This is promotion. Don't forget that. Promotion. Right? But what if we do this? Byte result. And then we say another byte, another int, okay, plus my byte. What do you think is going to happen? We get an error, right? Because we are requiring a byte is required, and we are providing what? An integer. So we're going down from a bigger one to a smaller one. So how do we resolve this? How do we resolve this? If we take a look at the previous one, we can do this, right? We still have a problem, right? So, guys, what do you think is the solution here? Do you have an idea? We are getting this problem here. Let me ask you something. What if I do this first? And if I do this, still get a problem, right? So what do you think will be the solution for this problem?
First,
What if we do
convert
this?
everything to int,
Good, good. Is that
and then convert
Eva?
the result to byte. Yes?
Good? That will be a solution. the entire result to convert it to a byte. Okay. So now, if we print byte result, we get byte result, then we get minus 116. Because bytes are working a different way, okay? The problem is that if the number is greater than 27, then you get a negative number. Because it goes from 128 minus 127 to 127. See here. So let's say that you have here number 2. Okay. You see? You get 127. But as the number is greater than 127, if you get 3, you see? Minus 128. Because, you know, if the number is greater than 127, you get a negative number. Okay? Because the first one, it goes from minus 128 to positive 127. So you put here 4. What do we get? 127. If you put here 5, what do we get? 126. And all the way, if you put 15, it continues going, and you get minus 16. Okay? So, very important. Very important. A byte goes from minus 28 to positive 127. Okay? It's a primitive, don't forget that. Okay? And it has 4 bytes. Okay? Don't forget that. No, sorry, it's 1 byte. Int is the one that is 4 bytes. Right? It's 1 byte. Remember I think I put it somewhere here. It's 8 bits, and 8 bits is a byte. Don't forget that. And then 16 bits. Int is 32 bits, which is 4 bytes. Remember that every byte has 8 bits. Okay? Every byte has 8 bits. That's why an integer has 32 bits, that is 4 bytes. Okay? Very good. Do you guys understand this? Understand this?
Yep.
Yes, yes.
So this will returns minus 116. Okay? Because 140 is greater than 127. Okay? So do you guys see it? Okay? If I put 2, what I get? 127, because it's exactly 127. But if I put 1 more, it just goes down to minus 128, which is the first number in the negative numbers. You see? If I put 1 more, it just continues increasing, 127. Okay? Don't forget that. Very important. Okay? So now, we're done with this part. Do you guys understand this? Yes, no, maybe. Maybe tomorrow. Maybe later.
Yes.
Are you learning? Well, by your silence, I see that you're not learning anything. Guys?
Yes.
Oh my God. Okay, we continue.
Thank you.
You're welcome. Let's continue. Let's talk about the Unary operators. Okay. Let's just create a class and let's call it Unary Operators. Okay. Let's create our dear friend PSVN. Right. And what is Unary operator? Let me got it here. Okay. Let me see if I can see here. An unary operator is the one that takes a single operand argument and performs an operation. An unary operation is an operation with only one operand. This operand comes either before or after the operator. Unary operators are more efficient than the standard JavaScript function calls. Okay. Let me see here in Java, right here, Java. So we see this guy. This guy. We're gonna see the result now. This is a guy that I'm looking for. You see? And we're gonna see them now. All right? Let me give you examples of that. So we have the unary operator. So let's just declare a variable int. Guys, before we continue, you know where to find the videos? You know how to, where to find the videos in the channel, in the YouTube channel?
Yes. Mm-hmm.
Everybody's clear about that?
Yep.
I think I put it here, and I think I put it here, and right here. The channel is here. If you click here on the pin messages, you can find the channel right here. Okay, Tech Greatness. Okay, that's where you can see the videos. All right, good. All right, so we have a variable here. Let's call it. Let's just give it just this. Guys, do you think that this is effective? Sorry, I didn't give it a name. X. Do you think this is effective? It is not a mistake.
No.
Right? It is not a mistake, right? But what are we using this plus here if by default is a positive number? Okay, so this is the plus symbol is redundant. Okay. Right? Is redundant. Redundant. Okay? You don't need that. So the correct way will be int equals 3. There's nothing wrong about this guy, but the plus is redundant. You don't need that guy. Okay? So let me print x, right? Just x equals, and then just x, and let me run this guy. What do we get? 3. Doesn't matter. Now let's print as x1. Okay, so let's say x1 equals, I put a comma here, x1 equals x1, right? So we say here, and then we guess this guy, x1, 3. So the plus is, redundant. We don't need that. Now, guys, what do we do this? What if we do this? Double y equals minus x. Okay, so what do we get now? If we print x equals x, and then we say, comma, y equals y, what do you think is going to be y? What do you think is going to be y?
Minus 3.
Minus 3.0. Don't forget that, guys. We have a double. Okay? And a double is a decimal. So it converts that integer to 3.0. Don't forget that. Very tricky in the exam. Very tricky. Okay? Whenever you have a number, let's say you have int my number. You say 10 or 12. And then you have double my other number. What are we doing here? We say my number, right? And now if we print this, what are we going to get? My other number. What do we get?
12.00. 12.0.
12.0.
Yes.
Okay, that's very important. Don't forget that. Don't forget that. What if we do this? So what do we get? 12.0. Okay, a float. Okay. We are assigning -3 because 3 is positive. And with this minus in front of it, before it, it makes this number negative. That's why y will be -3, but we have a double, and then we get 3.0. Now, if y is an integer, then we get -3, right?
Mhm.
But it's a double. Okay, don't forget that. Very important. So this returns okay. Good. And this returns 12.0. Okay, don't forget that. Don't forget that. We continue. Now we have another one. We have y equals -y, right? And then we say this. So what do we get?
3.
3.0. Because we're just making this guy. Remember the y before was -3? So we simply doing this. Okay? Or if you want to see it better, you're simply doing this. Okay? This minus multiplied by this minus is positive. That's why we get y equals x. I mean, y equals 3.0. Don't forget that y is a double. Okay? So you're going to get 3.0. Okay, so I'm going to put it the way it was before. Okay. Okay, so this is basically -1 multiplied by y. Okay, y was -3, so -1 multiplied by -3 is 3. Right? So this will be -1 multiplied by -3, right? I can put this in parentheses, and that's going to give you 3.0. Okay? Since y is a double. Got it? Nice. Now we're going to have this guy. I know that you know this guy. Remember Boolean? What is Boolean? What is a Boolean, guys?
True,
What is a
true,
Boolean?
false.
True or
True or
false?
false. Very important, true or false. So I say A equals true, right? And Boolean B equals this guy. What do you think? What do you think?
False.
Okay, so if I do this guy, just this guy, and I print this, I would say A equals A and B equals B. Let's see what happens. Okay, so if I do this, I get A equals true and B equals false. Guys, whenever you see this guy, this operator here, this exclamation point in front of a Boolean variable or in front of any operation like greater than, lower than, that means the opposite. Okay, so the value of A is true, and we're simply saying the true, it becomes false. Okay, same thing here. Okay, so if I just run here, what do we get? False and true. Okay, false and true. So basically, what we're doing is this. Okay, we're doing this because this is A, right? And we are turning whatever result A has, which is false, false. This guy here makes the true false, and then we're making that false true with this guy. So if I don't do this, we're gonna get it false and true. It's the opposite all the time. So let me just put it the way it was before. I don't want to confuse you. And we'll do it that way, and then we get true and false. Guys, again, value, okay? So if we say this, right? This value is the same as the opposite of value. Okay, that's for a Boolean operation. So whatever is true, like this, will be false. Okay. And whatever is false will be true. Guys, what do you think this will give you?
True.
Error. Error.
True.
True.
Oh my God.
Yeah.
So the first one is
This
the
is
first
false.
one is true, the second one is false, and the third one is true.
This is false, true, false, true. Okay, this is true, right? Right? This
Yes.
is false. And this is true. Got it? You want to see it more granular? So let's do it this way. Let's see what happens. You see it? This is true because this guy here, this exclamation point makes this false true, right? This guy here is true, just divided in pieces. So this is true, right? That's true, right? Because this exclamation point makes this false true. And this makes it false again. It makes it false again. And this is just adding one more, it makes it true again. That's why you have true, false, true. Do you understand it, guys?
Yep.
So this returns true. This returns false. And this returns true. Okay, let me remove this square brackets from here. Okay, guys, what do you think this prints? What do you think it prints?
True unlimited.
Error,
True unlimited, that's a good one.
error, error. What do you think it prints?
The first one is false, and then true. True, false, 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 true.
False.
False. False is false.
Let's see it. Hey, you got it. You see? Nice. Now, let's show you something. Let me show you something. Int my int equals this. Do you think it's going to compile? Let's see what we get.
Well, it didn't give you an error, so we'll see what it's gonna do. Now
That's
it did.
override type int for Unary operator. This is never used for.
You know, it didn't show the
Yeah, it
the
does.
little light bulb.
There's
The
a
light
red,
bulb on the left-hand side for error.
there's a red line under it.
Oh, okay.
Okay, that doesn't compile because you use that for operands, for booleans. Okay, so we say this does not compile. Okay, how about this one? Boolean, my boolean equals minus true. What do you think about this? Operand minus cannot be applied to boolean, so this doesn't work either. Okay, because you don't apply that to a boolean variable. This not compiled. Okay, how about this one? Boolean z equals this. So it gives you operator exclamation point cannot be applied to integer. Okay, so this does not compile either. Okay. Are we understanding, guys?
Yep.
Okay. Is it crystal clear?
Yes.
It may be a new concept for you guys, but you know, the more we learn, the more we understand it. Okay. Let's see the second part of this unary operator. Okay. So we continue here. All right. Okay, now we say increment and decrement. Be careful. Okay. Be careful. Have higher precedence or precedent order than plus minus multiplication, division, and others. Okay, so you can sometimes, I mean, if you have any doubt, you can refer to this table that I put here, and it's going to help you. Okay. Okay. So as you can see here, increment is double here. Decrement is minus, plus, minus. They have more precedent than multiplication, division, modulus, addition. They have more precedence than those. Okay. Very important. So we have int my int equals 5, right? So we can say my int equals my int plus 1. Okay. And then what do we print this? What do we get? And then 6. Okay. Now we can do this. Int other int equals my int. Okay. What do you think is going to be the value of other int? What do you think is going to be the value of other int? This guy here. Guys, the value of all the ints.
6.
6, right? Because we're just reassigning, we're just assigning this value that int has, which is 6, to other int. Okay? Now, let's do something. Let's say this int, and let me just comment this other int. And let me put here int is equals new int plus plus. Oh, my int, not new int. Okay, so what do you think is going to be the result of this?
6.
7.
Okay, let's just print that. So we're going to say my int equals my int, and then my other int equals other int. Let's print that. Good. Okay. So we're just, you know, my other int is 6, right?
Mm-hmm.
And my int is 7.
So use and then increase.
Yes, correct. Right? That's why we assign 6 to other int, but then we increment it, and then we get 7 because we got 6 here. Okay? So this returns 6. And here, my int becomes 7. Don't forget, use and then increment. Okay, so this returns. I just put these comments, guys, for you to understand it later, just in case you need to go back to this and visit this. And you can see the flow of this, okay? Now let's have a count here. Int count equals 0, right? And let's do something real interesting here. Let's say sys out, and this is real interesting, okay? Count. Okay, so now let's do this. And let's do this, and let's do this. And let's do that, okay? So, guys, what do you think is going to print here? Tell me.
The first one is 0. The second one is going to be 1. And the third one is going to be 1. The fourth one is going to be 0. And the fifth one is going to be 0, I think.
Guys, do you agree? What if I tell you that the square was going to be 0?
No. 1,
1,
Uh-huh.
and
0.
No.
It's going to be 1. 1.
Ah, okay. Yes.
And this one?
0.
0.
No. 1.
Oh yeah, 1.
And this one?
And
0.
0.
Okay. Remember, this is use and then decrement, right? So it's going to print 1, but count becomes
0.
Right? So this one, count was 0 and becomes 1. Let's see it. You see it? So be careful. Be careful. You just keep it 1. You print 1, but it becomes 0. And then for the next time that it prints it, the value is 0. Okay, what if I do this?
Zero.
And what if I do this?
-1.
Makes sense, huh?
Yes.
It's very interesting. Very interesting. Okay. What if I do this?
-1.
And now?
0.
Are you guys understanding? Are you guys understanding? How about this one?
1.
And how about this one?
1, 2.
Got it, eh? You see? Yeah, that's very interesting. I mean, you guys need to understand this for the exam, okay? You need to understand this for the exam. Now, let's see some questions for the exam, okay? Some of the questions that you see in the exam questions, okay? So let's say int e equals 3, right? And then we have int f equals plus plus e multiplied by 5 divided by e minus minus plus minus minus e. What's the result of e and f? So what do you think?
E is 3 and F is 8, I think.
Pretty close.
I say it's 8.
Oh, F is 7. E is 7. I mean, E is 3, F is 7.
Let's see it. E is 2 and F is 7.
Oh yeah, E is 2. Yeah.
All right, let's see it. So beginning A equals 3, right?
Yes.
Right? So now we continue with this. So we say 4, right? Because E becomes 4 here, right? 4 multiplied by 5, right? And then is, let's say that this is E minus minus, right? Is the same plus minus minus E, right?
Mm-hmm.
I'm sorry, not 2, it's only 1. Okay, right? So that's the same as, so let's say the plus E, right, is the same as plus 3, right? Because E is 3. And that becomes E equals 4, right? So that's the second time. Third time now, we still have 4 multiplied by 5, right? And now we have divided by 4, right? Plus minus minus E, right? Remember that E equals 3, okay? Don't forget that. E equals 3. So we say this, which is the same as E equals 3, right? Because we are decrementing E. Remember that was 4 before, now is it 3? And that's the same as E minus minus, that is
2.
4 minus minus, which is the same as 3. Okay? So I don't know if you're understanding here, guys. Okay. So we're trying to resolve this guy. Okay. Okay. So now we're getting 4 multiplied by 5, right? And then we have 4 plus 2, right? 4 plus 2. Now that is minus minus 3, right? Which is E equals 2, right? This E here, which is this one here, it becomes 2. Remember? Now we have 20 divided by 4 plus 2. And now we have 5 plus 2, and that is 7. So F will be 7 and E equals 2.
You know, I took it from left to right.
Yeah.
That E will change each iteration from left to right.
Mm-hmm.
And that's not the case. What it's doing, what you're saying is that each E on the equation is.
Don't forget that these guys.
It starts from the original value of E.
Yeah, but don't forget that these guys, they have more precedence than this one.
Yeah. But what I'm saying is that E.
Okay.
And the first one becomes 4, right?
Right.
But then I was thinking, now that it's 4, it's used then increase, right? So it goes 4, and then the next iteration it will be 4 minus minus, because you already changed it to 4.
That's right.
But that's not what it's doing.
No, it's not the same iteration. It's whenever you see an E, the E is.
It's doing a substitution of E for the value of E, not.
Correct.
not an iterative value of E throughout the equation.
Yeah. Every time it sees E, it will alter it.
You understand what I'm saying?
No, I don't.
Okay, so my thought it was that E would change as the value changes of E throughout the equation from left to right.
Correct.
But that's not what it's doing.
Okay.
What it's doing
so-
is substituting the value of E in the equation and then doing the mathematical operation.
Here is 4, okay? But when it gets here, it's still 4, but it becomes 3. The value becomes 3, but it's still 4. It's using 4, okay? Now, when it comes here again, is get that 4, or actually it gets here
It gets to
4.
be 3.
4, and it makes it 3, okay? It's right here, you see?
3, and then it becomes 2.
Correct. Becomes 2 here. So it's just in the same line. Okay? It's just in the same line. It's not like a loop that is iterating, and it's just the same line, but you have to respect the order of precedence. Okay? It's just giving you this for you to see it more clearly when it becomes the number it becomes. Okay? But it all happens in the same line. Okay? So the value that the E has, as soon as it encounters another E, it will alter it. It was just whatever is here. Okay? So here we use 4, but E becomes 3. When it comes here, E becomes 2. Do you see it?
Oh,
Do you
sorry,
guys-
I'm talking on mute. Yeah, I can
Yeah.
see it now.
So here is 4.
Mhm.
Then as it moves to the right, here it continues to be 4, but the value is 3. Remember, you use and then decrement, right? So it's 4, but the actual value right now is 3. You see there?
Uh-huh.
I hover over it and it's showing me 3, right? And then here is still 3 because, it has to run it, right? It has to run it. But the value is 7 and 2. Don't forget that when you see the symbol is increment and then use, and if you see after that is use and then increment or decrement. That's very important. Let me give you another one. Give you another one because you have to practice. Okay? So we say int g equals 6, int h equals 2, and int I equals plus h plus minus g multiplied by 3 plus 2 multiplied by g plus minus h minus modulus minus g. Let's see what you see there. What is the value of g? What is the value of h? What is the value of I? One more reason not to do the exam at home, okay? Because it's hard to do this with your mind.
Oops. Hello?
You need the screen?
Yeah, I lost the screen. Where are you?
Oh, no, I just wanted to run it and I'll show you the answers. Okay, go ahead.
Okay. So it's two.
I have a mambo jumbo.
3, 2. And choose. So that's 3, 6. Okay. 7 plus 2 times 6. Minus 2. This is oh. This one, this will be 15 minus that's this. Oh, okay. So this is 1. Move on. So this is
So that would be 2. That would be 0. So would it be -1? Yeah, okay, 25. So 2 plus 15. And so it's 2, 2. So 2. No. Two times 5.